Okay, so I'm just going to go over project 3, which is Minesweeper. Okay, so in this project, you guys are going to be building Minesweeper, like in the actual game, so the actual application, which is pretty cool. So this is just a general overview on this first page here. So if you guys aren't familiar with Minesweeper or know how it's played, you guys can go ahead and click on those links and kind of learn it. It's a relatively simple game to learn and understand, so I'll leave that for you guys. He gives a description of the rules. Let me zoom in here for you guys, actually. He gives a general description of the rules and also talks about the features that will be implemented for your guys' project. So you'll need flags, the mine counter, and the restart button, along with everything else the game provides. And then the non-standard features that you guys will need are the debug button and the test buttons 1 through 3. So these two features, the non-standard features, these aren't something you're going to find out when you go play Minesweeper like online or on your computer. This will be something specific to this project, and we'll go over what those two things do. So this is talking about the window and board setup. So basically, we are going to provide you guys a config file. It's just a fancy name for a text document. You can read this in using the get line call. So what these three attributes are in the text document, this first line is just going to be the width of the board. The second line is going to be the height, and then the last line is just the number of mines. So when you guys actually boot the game up, you're going to read that config in and create your board based off of those three attributes in the text document. Yeah, so that's pretty much that on the config file. This basically means you can't hard code the size of your board. You actually need to make this dynamic and be able to change based off of what the config file is. So not like dynamic memory, but dynamic in the sense that it needs to load something else. So if we go in there and change the configuration file, it should basically, when you reboot the game, it should be a different size. Okay, so for the SFML stuff, this is a library that you guys are going to need when you are doing this project. You definitely need this. A lot of the instructions on how to set this up on your machine can be found on Canvas, so you guys can go check that out. The basics of this SFML are the sprites, the textures, this vector, and the mouse. So the textures are basically just going to be images that your program needs, and your sprites are going to be made using the textures. Sprites are something that will actually allow you to draw objects onto the screen. So that's actually how you get the visuals onto the screen. With this two-dimensional vector, you can basically, I think, figure out where stuff is stored to actually write it onto the actual game itself. And then the mouse, you can find where your mouse is at, which is going to be helpful when you go to click on things. So you can find the actual coordinates of your mouse when you're clicking on different objects in your game, which will be helpful because you need to do something when someone clicks on your game, right? So there's a couple different tutorials that I'll leave you guys to go mess around with. Those should be pretty helpful to look at. And the first milestone for this project, which is going to be due next week. I'm recording this on Friday. So I'm recording this on Friday, April 2nd. So it'll be due next week. And you basically just show your TA the green circle. That green circle is just code that you can run from the SFML library from their website that will basically just load up a green circle that's displayed. And this is a pretty easy extra credit, 5 points that you guys can get. This is actually on top of the 20-point cap in the course, right? So you can get this 5 points on the actual Project 3 assignment itself. And same for milestone 2, you can get another 5 points for doing a few things here and there. So if you have any questions about that, just get with your TA and they'll let you know. So right here, he's just warning you about using textures as global variables. So you don't want to do this, and we'll actually deduct points if we see that you are doing this. So just make sure that you have this at least in main, right? At least in some kind of scope. So not all of your functions can touch the texture objects. So these are all the images that you'll use within your game. So these first things, just the mine, the tile hidden, tile revealed, the number. This will just basically be the number that you want to display. So there's 1 through 8. There's 8 of them, and then the flag. So these are going to be what you're going to be loading into your textures. and then you're going to create sprite objects from those textures. Okay, and that's how you're going to be able to display them onto your game board. Same with these, the smiley face, the win face, and the dead lose face. For these digits, it's a little bit different. So you actually need to get specific pixels from this digits picture here. So basically in the top left, I believe is 0, 0. So moving to the right, each one of these digits has the width of 21. So it's going to be a 21 pixel offset for each of these numbers. So if you wanted to show like the number, 24, you'd have to be offset by 42 just to start getting the 2, and then you'd have to be offset by another number to get the 4 here. And that's how you basically will display that. And your like SFML library actually just takes in a pixel, I believe, as a parameter with when these sprites that you want to display, or it might be within textures. But you won't have to actually like hack this photo up yourself and like store these as different images, or do anything like we did in project 2, right? This is strictly using the SFML calls, and you just tell it the width and height of the pixels that you need from the specific image. This is what your debug button will look like in these 3 test buttons. We'll go over these in a little bit on what they're actually going to do, but this is just what the buttons look like. So we're talking about other features here. So with the buttons, this is basically just explaining how buttons are going to be used. They're going to be made with a sprite, and then based on your mouse click, it will basically figure out which sprite was clicked on and do some kind of action when the user clicks on it, right? So there's no actual like button like object that you're going to be making. It's just going to be sprites and then figuring out what happens when you click on that certain location that that sprite is at. Okay. So this next section is pretty important with the adjacent mines and tiles. So one thing that we highly recommend is that your tiles, which will most likely be a tile class, your tile class or your tile object will have a vector of tile pointers. So you can see this. You can also make this an array if you want. That's perfectly fine. I find the vector a little bit more easy to work with. But if you have a vector of tile pointers, basically the tile pointers that are going to be stored are going to be the pointers or the tiles rather that are adjacent to your actual tile itself, right? So it basically understands who its neighbors are, right? And if it's the case where it doesn't have all 8 neighbors, you should be storing null pointers in there. And that will come up and be helpful when you deal with your recursive algorithm to actually make this reveal happen. For those of you who are watching this video that are familiar with Minesweeper, you know that when you click on a tile, it basically spreads out and reveals a bunch of tiles until it hits like a line of numbers, right? So that functionality is going to be using recursion, and that recursion highly is dependent on having this vector of tiles set up within your tile object. There's obviously tons of ways to do this differently. Programming is pretty interchangeable with what you can do, but this right here we believe is the best approach, and I'd highly recommend doing this. It's going to be really helpful to know whose neighbors that tile has, right? Okay, so this is just going over the config file again and giving more of an example of what's actually happening. So you can see if we look on the left-hand side, that's 22 by 16 with 50 mines. And then on the right-hand side, it is 35 by 20 with 50 mines. So it has the same amount of mines, but the actual size of the board is different. And that's what we're basically expecting in behavior when you change these config files. So we provided only one example for the config. So you'll actually have to either make another one or change the one you have to make sure that that functionality is there. Okay. Okay, so this is going over loading boards from files, and this kind of goes in with the test boards themselves. So your test boards, basically when you click on these buttons, they will display a different type of board. It's not just going to be randomly placed mines. It's going to be a predetermined mine layout, and that's based on the board file that you're going to actually read in. Okay, so it's a BRD file, but it's basically a text file. So it has a bunch of ones and zeros, and not even in the sense of binary, but like actual ones and zeros that are typed up within the document. So you can open those up and take a look at them. But all the ones are going to basically represent mines, and all the zeros are going to represent just blank tiles. Okay, So you can see based off test board 1 and test board 2 that you can see where the ones are at basically represents all the mines. So this test board 1 only has one mine, and then this test board spells out test 2 with the mines. Uh, so basically, we expect you guys to be able to read in these board files and make a board based off of those board files. Um, we provide you three, but it's possible that we're going to test these with other boards, right? So we can basically just change the names of them and test them with different boards. Something that's important to note is that when reading in these test boards, they will only work with a certain config file, meaning 25 by 16. So if you run these test boards with a different configuration file, they're not going to work, and that's okay. We're not going to be testing for that. Your test board should work with the correct config file size, but if you change it to something different, it's okay if the test board layout isn't quite right. That's just what the test board depends on. So. Okay, code structure. So this is what a lot of people come to ask questions about and understand. So, you know, the further you've got in this course, we've kind of let you do more and more on your own thing, and that's kind of what we're doing here, right? So. How you choose to make this work is totally up to you. He mentions if you want to write it in a gigantic main function, you can do that. Hopefully, at this point, you realize that's probably not the best approach. So a couple recommendations we have is creating a class to represent the board. So if you have a board class, then you can have a, maybe a two-dimensional vector of tiles within that board class where tiles are their own class, right? We kind of talked about that a little bit earlier, where your tile class could have a vector of tile pointers to represent the neighbors, right? So this is kind of the relationship that you'll probably have. Another thing that he mentions is that your program should have a pretty solid way of resetting all the information within it. So that means like clearing out your vectors, maybe resetting different textures or sprites. So make sure that you have that in the back of your mind when you're building this. This project specifically is something you'll probably want to plan out pretty well. Get a good understanding of the problem you're trying to solve, and write out exactly how you think it should be laid out with the different classes and the way you're going to structure your program. I think this is a project that you can get kind of lost in if you don't do that pre-planning and understand exactly the path you're going to take, right? Some things change, but you should have a general guideline of where you're headed. So for the paths, this is similar to everything else you've done in this course where your paths need to be relative. So really the only thing that should be in here is just images / whatever image you need. And same with the boards, right? Board / whatever the board name is. Make sure you're using forward slashes. This is only going to work in Windows. So if you're on a Windows machine, make sure that you're doing it this way, especially when you turn it in. So for the mouse interactions, he basically is talking about what to do when you're clicking. So you need to check where they clicked. You can do this by getting the mouse coordinates from the SFML library. Did the player just click a mine? So this is basically thinking about, where did the player click? What should we do if they clicked on a certain sprite? And then revealing a tile. So this kind of goes in with clicking on a mine, like what to do if they clicked on the tile themselves. Here he talks about the recursive algorithm that you'll probably need. We think this is probably the best way to do it and the most efficient. There's a lot of tiles to be revealed in a pretty quick amount of time. So doing it without recursion is pretty cumbersome and can probably take a while to actually reveal the tiles. So I believe the algorithm you guys can look into is called depth first search. So DFS. If you guys look that up on YouTube, you should get a decent understanding of kind of the algorithm that you're going to end up making for this recursive reveal is what we call it. So I think I talked to a few of you that you have a chance to use a map in this project. So that's how you can store your resources. So if you remember from like page 6, I think it was, is there's a lot of images that you guys have, right? So as opposed to constantly having to reference those by its image name, like, images / smiley face or whatever it is, you can actually store this inside a map. So you can store the actual path name inside the map as the value and just store the key as whatever that name is, right? So you can say like smiley face as the key, and then the actual value will be the string path name. So when you're writing your code, you can just reference that map at that key, and it might be a little bit more readable, right? So using documentation, this kind of blends in with the tips. The biggest thing is you guys are using a new library, right? You guys are using something you're probably not familiar with. While the TAs and everybody can help you out, it's really on you to go through the documentation, understand what you're using, just get familiar with the API calls that you're doing with this SFML library. A lot of times that you can just find this information online through the documentation and kind of get an idea of what's happening. Another good tip here is don't be afraid to experiment. So definitely, just mess around with what the library is actually doing, even if you're not programming to what you're trying to build. If you get a better understanding of what all the function calls do, it'll make you that much stronger when you actually need to implement them in your own project, right? So that means just draw a couple things here and there to the board. Click on a few things, make sure that your clicking is doing the right thing. Most people just do a little print statement every time they click, right, to make sure that their clicking is working. It's different things like that that are going to basically build up to the actual project. This is kind of similar to project 2, where you guys just read in something, wrote it back out, and just made sure they look the same, right? It's all these baby steps that will pay off in the long run, as opposed to be getting lost in the weeds because you didn't really know what you were doing in the beginning of the project, right? So those are some good recommendations. So for the submission, similar to project 2, you're just turning in your source files. So your .h and your .cpp files, and you can zip those up and then just make sure you name them correctly, right? So that makes it easier for us to grade your work. And let's see, anything else on the submissions? Yeah, we don't need any like images or like the libraries. We have all of that set up on our own machine, so we'll just dump your files in there and compile and run with it. So all we need is your code. So for partial credit for features that work partially, this is going into how we're going to grade this. So you will obviously get full points for features that work perfectly with no bugs of any kind. You're going to get half points for features that have any bugs at all or is only partially implemented. And then no points if the feature is not partially implemented at all, or it's just so minimal that you can't really do what we're trying to do, right? A couple of the point deductions for this one, if you use the global texture variables, kind of like or objects rather, that we talked about before, and then -10 for not using a relative path. So if we have to go into your code and change your paths around, that's also going to be -10. This rubric basically goes over each piece of functionality that you need. When you are thinking about how we're going to grade this and thinking about how many points you're going to get, just run through this rubric and take a look at it and just see, is it doing exactly this? And you'll most likely get the points for it, right? All the TAs follow this rubric pretty strictly, just so that it's fair to everybody and as much subjectivity is knocked out of the game, right? So just an example for the config file read. So this very first portion of the rubric, that's worth 8 points for doing this correctly. So for instance, if we can tell that you're not reading in the config file at all, like you don't have this functionality built in at all, that's just going to be 0 points, right? If we can see that it can read some sizes incorrectly, but other sizes, your board looks a little bit weird, that'd be like 4 points, right? And then if you are doing it correctly, you can read in every different size. The board looks great. That's going to be the full 8 points. Okay. And then you basically just kind of run that process through the rest of these, right? Like how much does that functionality work? And one thing that happens a lot is students want us to basically pre-grade their work. So you basically send us the stuff and ask if we can make sure everything works. That's kind of on you guys to make sure that it's working. It's just like project 2. You need to do the testing. You need to make sure it works, and then you can submit it, and the grade you get is what you'll get. And that's just basically how it's going to be for the rest of your CS careers. Definitely at UF. And then when you get out in industry, right, they're not going to pre-grade your stuff. They're not going to look at it. They're going to just want you to present the project, right? And that's kind of what's going on here when you turn it in. So Yeah, that's just basically all the rubric. And then he gives a few example images here, basically kind of what your game should look like. Right. Uh, cool. So I think that's pretty much it. That's the whole project. Reach out to any of us if you have any questions, and best of luck.